Hello and welcome to Grade 9 Math. We're jumping to Unit 7 now and starting that new unit under data management or data relationships, still focusing on mostly linear functions with nice straight lines. And we're into Lesson 1, Interpreting Scatter Plots. So you may have seen scatter plots, you may have done them in science class. And so it's when you have a bunch of data and you have to put those points on a graph, and then you see if there's a pattern. So by the end of this class, we will be able to interpret the meaning of points on a scatter plot and describe trends and relationships observed in that data. Okay, so when we are interpreting scatter plots, a scatter plot is a graph of plotted points, which can be used to determine if there's a relationship between two variables. The two variables in a scatter plot are independent variable and dependent variable. Okay, so these are two very important definitions to remember. So you need to read these over a couple times. So the independent variable is the variable which is known and it's graphed along the x-axis. So the independent variable is the x value. The dependent variable is what is affected when the independent variable changes and it's graphed along the y-axis. So we often think of as the x changes, the y value will change with it. Okay, if I get so examples, hours, as my hours change, okay, example, my pay changes, right? Or time and rainfall, as more time goes by, more rainfall hits. So, in other words, my pay depends on hours worked. It's not the other way around. We don't say someone doesn't pay us and then we go, oh, now I owe them 5 hours of work or something. I guess you could do that, but it's not tends to be the way we do it. So let's look along here. So here is my independent variable. And here's my dependent. Along the x-axis, or the y. So here's the y, here's the x. X is independent, y is dependent. Okay, so in this case, we have a local ice cream shop, keeps track of how much ice cream they sell and the temperature on that day. They record their findings. So if you were to make a prediction, just looking at this idea that on hotter days, they'd probably sell more ice cream, and that's what they're trying to prove here. On colder days, they're going to sell less. So what's more dependent on the other? Is the temperature depending on how much sales, or does the sales depend on the temperature? So if you could try to put it into both sentences. Okay, say the ice cream sales depend on the temperature. Okay, or do we say the temperature depends on the ice cream sales? And when you read them out to yourself like that, I think then it becomes pretty clear. Basically, the sales depend on the temperature. So what is my independent variable? I mean, I already kind of showed you guys, but you have to sort of think about this quite importantly. So our independent variable is the temperature. Okay, in degrees Celsius. And that means the dependent variable depends on the temperature. We get more sales in this case in dollars. All right. Now, then how else can we use our are scatter plots? Well, they give us information. So here it says on the days they tracked, one of the days they tracked was 22.5 Celsius. Circle that point on the scatter plot, and what were the sales that day? So again, you kind of have to guess a little bit here. It goes by 2, so here's 23. So we're kind of looking at in between of there. And there we have it. That was the one that they recorded. If you could, we call this interpolation. If the values are inside the known data, we say interpolation. We already talked about this, so I just wanted to repeat it. We're interpolating. Now we go across, and where do you think we're hitting here? Well, let's just make a guess, but it's pretty much in the middle. Okay, so what were the sales for that day? So therefore, the sales were $450 that day. And you could repeat this over and over again. They could ask you all about those points, or you could say, find a point where the sales were at 400. Then you could find that point, or at 620. Okay, at 620, that was a really hot day at 25 degrees. So you could go back and forth and figure out different information. Okay, so that's how we use a scatter plot to gain information. Really important that you remember the dependent variable and the independent variable. Independent is on the x, and the y is the dependent. So, okay, so once we see a pattern of plotted points, we can kind of relate to them in different terms. So describing a relationship, we call this a correlation. In other words, does x relate to y? Is there a correlation? So y does depend on x, in other words. If we see, okay, if it's strong or weak. So if the points nearly form a line, okay, then the correlation is strong. So if we see that this is a okay, we have a tight oval. Okay, that is strong. All right. Now, if we see a large oval or wide oval, maybe we want to call that narrow and wide. A narrow oval and a wide oval. So if we see wide ovals, then it's weak. This is narrow. This one's narrow also. So it's a strong correlation. If this is a wide oval, then it's weaker correlation. There's still a correlation. You still see the trend going in this direction. Sort of see this trend going up in this direction. Now, what if it's just what if it's just the oval so wide that it becomes a circle or a big mess or a big mess, in other words? Well, there's no correlation. In other words, we're testing two things that have nothing to do with each other. Like the time of day and the color of the car driving by. There's no correlation to that. Okay. The weather and the stock market. maybe someone might argue that there is, but there's no distinct pattern. There's no pattern. Okay. So a tip to visualize, well, we talked about a thin oval, a wide oval, or a circle for no correlation. All right. Very good. All right, so let's look at this, describing relationships even more. We can call this correlation, we can define it as a positive or negative. So in a positive correlation, we rise up and to the right. Okay? These are positive. Then we can have negative correlations, falling down and to the right. Now, negative doesn't mean bad. Negative just means in terms of looking at the line, we are going, but both are, in this case, both are rising, right? We have a rise, these are rising and this is rising. Okay, in this case, this is rising, but this is falling. So overall, it's a negative. All right. It doesn't mean anything bad. It doesn't mean this is a great result. This could be your debt. You are increasing debt in a positive pattern. Over time, your debt is rising on your credit card, let's say. Or this could be, look, this a negative could be actually a good thing. Like, here's my mortgage, and over time, I'm paying off my house to the bank. All right. Now, this means that as one quantity increases, the other decreases. Whereas a positive, both quantities are increasing. Okay, refer to example, our graph from example number 1. How would you describe the correlation between temperature and ice cream? So we want to say, first of all, is it strong or weak? We want strong, weak. We want positive, negative. So we want to make that as part of our statement. So therefore, example 1, our ice cream sales have a, here it is. Well, what do you think? Would we form, um, what kind of oval would we form? A thin oval. Okay, so our oval would be a strong and which direction are we going into? Well, we're going up and to the right. So we would have a strong, positive correlation. Strong, positive correlation. All right. Good. That's as simple as it gets. Like I wrote more than you had to, but you're going to say it's a weak negative or a weak positive or a strong positive or a strong negative. All right. Okay, in example 3, we have to come up with some of our own scenarios. So let's say, what would be a positive correlation? Let's try and do it so that we have our independent first, variable, versus our dependent variable. So think about this. A positive relationship. So, well, I have an example here. So let's say the popularity of an athlete and the sales of their shoe. So which one depends on the other? Well, the shoe sales depend on the popularity. So the popularity athlete popularity and dependent variable shoe sales. All right, right? As the popularity of the athlete grows, they will sell more shoes like LeBron James or back in my day with Michael Jordan. Okay? So now negative correlations are a little bit harder to think of, but I have an example here. I did use the example of like paying your mortgage. So let's say your independent variable was, let's say, years, and your dependent variable, mortgage amount, right, remaining. Okay, so that would be one. I had another one. Let's say negative. Well, the let's say independent. The amount of protective equipment and the number of injuries. So let's say uh, protective gear versus number of injuries. Right. Another one. What about this one, you guys? Uh, YouTuber popularity versus number of views. Sorry, I don't know why it's so messy to write with this smart pen today. Then we think of like, what about a no correlation? Like, what things have no correlation? Well, I have a silly one here, but the height of student and math mark. There seems to be no correlation between the height of a math student and the math mark. Okay, so that's another thing. Here we go on to example 4 now. So sometimes we have information that just doesn't quite fit the rest of the data. And we call this an outlier. An outlier is a point that does not follow the pattern of the rest of the data. Outliers can be caused by an error in gathering data, or they could simply just be data point that does not follow a trend. You might think of yourself as an outlier. You're different than the trend, or you're a unique individual. So this is where we have our outlier in this case. He does not follow this trend that's happening. All right, so a class's results for a test were recorded along the amount of time spent studying for it. The results are given in the following scatter plot. Identify the outliers in the data and suggest a reason. Okay, so this idea that I study a lot. So I studied an hour. I only studied an hour and I got a lower mark. Okay, lower studying, lower mark. So it's a positive. More studying, higher mark. More of a positive trend. Okay, so most of the time, if you studied a little more, like this person studied 2 hours and they're in the 80 range, most of these people. You study upward almost an hour and a half, and you're, sorry, 2.5 hours, then you're up in this 90 range. So what happened to this person, this outlier? Well, they studied a lot. They studied 2 hours. Most people are getting in the 80s, and they're down in the 65. So what could happen? Well, lots of things. So here we go. So identify an outlier in the data. So what could be some, there's no clear answer here, but we're saying that there could be reasons. Well, um, they are just not naturally strong in math. Okay, maybe they studied the wrong material. That happens, eh? Sometimes you just study the wrong thing by mistake. What else could be? Maybe they reported an inaccurate time. Okay, they were distracted by the device, by their device most of that time. Who knows? Hey, maybe you're at home and everyone's loud in the house and you can't even study. That could be a problem. Okay, so it's this kind of thing of identifying, strong, positive, or weak, negative, no correlation. We're identifying outliers now. So you learned quite a bit in this one lesson about data. Oh, yeah, so there's practice now, and we can do these practice questions. And just to remember, okay, so scatter plots are used to determine if there's a relationship between two variables. To see the dependent variable actually depends on the independent variable. So here we have independent, dependent. This values of this variable should depend on these values. So this depends on this. What else? We have different correlations. So we have a strong negative, strong positive, weak negative, weak positive. This scatter plot shows no relationship. So that sort of summarizes it all. And there's even a few, no, that's all you have to do for this. So all these nice practice questions. All right, thanks for joining and watching, and we'll see you next time.